Do you hear me?
Yes, yes, Ali, we hear you.
Yes.
Welcome everybody for the second day of our workshop. Today we will have Dartmouth as a chair. Before I give the word to him, I would like to thank the LREC committee, language resources, and the aviation conference organization committee with all these support in the hard times. So I see Nicoletta and Khalid here. Highly appreciated, and it really made a lot of things possible and easier. So we are thankful to Doug Bond and our keynote as well, Philip Schrodt, and hope this event gets even better than yesterday and more in the future. So, Doug.
Thank you, Ali, and good afternoon to most of you in Europe and morning in the States. I have the pleasure today of introducing our first speakers, I guess, on supervised event coding from text written in Arabic. And the speakers are Javier Osorio, Alejandro Reyes, Alejandro Beltrán, and Atal Ahmadzai, and I apologize for the mispronunciations. And I want to encourage you, as they speak, to feel free to raise your hand. I will make a note of the order in which they were raised, and then we'll call on you afterwards unless the speakers want to respond during their presentations. And to raise your hand, it's in the bottom right-hand corner of the participant list. There are 3 dots. You select the 3 dots and you select raise hand. So without any further ado, I'll invite the speakers to commence. And I think, I'm not sure, I think you might have been told already in the chat, one of the second paper is no longer, it's withdrawn. And so we're going to go directly to Phil Schrodt's keynote after this discussion. So please go ahead.
Thank you very much. My name is Javier Osorio. Let me share my screen. Can you see my screen?
Yes, perfectly.
Excellent. Thank you very much. Good morning, everyone. Thank you very much for being here. For me, it's super early. It's 4 in the morning. I hope it's not that terrible for you. Thank you very much for being here and for the organizers for putting together this really good conference. Today, I'm going to be talking about supervised event coding from text written in Arabic, where we introduced the first version of Hadath, which is a preliminary functioning program for coding in this language. I'm going to be talking about the motivation of the project, the machine learning application, the natural language processing, and then the specific examples of results that we have from this round of the program. This is a program that the nature is focused substantively on analyzing ARM actor governance. And this is part of a project from the US Department of Defense through the Minerva Research Initiative, where we analyze how armed groups not only engage in violence, but sometimes they also provide public governance and public goods to the communities where they have control on. This project has 2 branches. One is on Colombia, where we use Eventos ID, which is another software that is developed, which codes events in Spanish from Spanish news stories. But for Afghanistan, we needed something else. The software that we had considered initially was UD Petrarch, the Universal Dependencies Petrarch, that largely relies on the Keynote ontology. As I'm sure we're going to learn later today from Phil, this Keynote ontology was not very well suited for the type of analysis that we were trying to do, because we're trying to analyze subnational actors engaging in behaviors that are not already considered under the Keynote ontology. So we decided to go a different route and start developing our own coding capabilities for this particular project. The first challenge that we had was like, okay, yeah, we need something to code events in Afghanistan, but Afghanistan, they speak 3 languages, Dari, Pashtun, and Uzbek. Yes, they are based on Arabic script, but it is not modern standard Arabic. So why do we ended up coding something in Arabic, which is not the original language of Afghanistan? It was pretty much a practical decision. We had, at this stage in the project, we have more resources in terms of text, also human coders and NLP and machine learning capabilities already standard for Arabic. And we decided to start here as a broader strategy that eventually could be applicable to a broader set of cases of Middle Eastern countries or Arabic-speaking countries, rather than going specific straight to Arabic, to Dari, Pashtun, and Uzbek. And once we have the Arabic capability, we can more easily adapt the dictionaries, which is all that will take for the specific languages of Afghanistan. So in this particular example, we present the basic functionality that we have for event coding, supervised event coding from Arabic script. And we implement this in two stages. The first one is machine learning for the classification of news stories that should be relevant to our case study, and then the natural language processing with the application of Hadath to the specific corpus that we gather. So the first part of the machine learning application to select news stories as the source of information, we rely on Nexus Uni, which is this global connection of newspapers from LexisNexis that includes newspapers in Arabic. We gather information through a very sophisticated query from 2008 to 2018. So we have a good temporal coverage. And these, the result of this search gave us 100,000 individual news stories. When analyzing the specific content of these 100,000 news stories, we realized that, of course, this is imperfect. Not everything was relevant to the specific objectives of the study, which were primarily focused on acts of conflict or governance taking place in Afghanistan. We wanted to find events, but we realized that we have many opinions or statements about the events themselves, not the actual events that took place. And those were not very useful in terms of the quality of the information that we had here. And we also had a lot of opinions of international actors, as you can imagine, about the security conditions in Afghanistan. And those were not relevant. In addition, we had a good share of noise in the news stories. So we needed to clean all that information to really focus on what was relevant. We gave a set of human coders the task to accept or reject the news stories based on the characteristics of the project. They manually annotated half of the corpus, basically 55,000 stories. 31% of those were accepted and 68% of those were rejected. But still, there were like some few areas where we needed an additional set of precision or calibration. So we further commissioned a sample of 1,000 articles to our human coders. The three of them coded the same exact corpus. We reached high levels of accuracy, and with that coding of 1,000 stories, we trained a little model that allows to identify about 4,000 news stories where there was a discrepancy between the human coders and the software, and the machine learning model, and that helped us to recalibrate the entire training data. At the end, we reduced the number of accepted articles to 29 and increased the rejected ones to get rid of these disagreements. And those 55,000 stories were the ones that we use for the training data. For the complete machine learning classification, we use cross-validation, breaking the entire collection of stories in 5 subsets. They represent for the validation. And then we tested a variety of models for the application in terms of their performance using the F1 score. We use convolutional neural networks in 2 versions. One was with a kernel size of 3, another one with 5. We also use random forest, naive Bayes, extreme gradient boosting, SVM, and linear regression models. This graph shows the results of the F scores for the different models in terms of the accuracy in the performance. The multinomial base was the worst in terms of performance with an F-score of 0.835. And the two best models were the SVM and the linear regression model. The support vector machine had an F-score of 934, and the linear regression was slightly better with 938. So we ended up using this one, the linear regression model, for the entire application of news stories classification. After applying the linear regression model, we ended up running everything with 100,000 stories, selecting about 26%, which is 26,000 relevant news stories. And those were the ones that we used as the corpus for the natural language processing stage of the project. So for the NLP component, this is where we start running Hadath to identify events written in Arabic for Afghanistan. So Hadath is it's a very basic, old school, like probably way too old. We use sparse parsing, so there's nothing fancy here yet. But the software pretty much relies on a set of rules that come from dictionaries of actors, verb patterns, and locations. The software can identify or geolocate information at the department, which is the state level, and also the district level, which is equivalent of counties in the US. And then we also have a set of location filters to clear geographic disambiguation. The way the software works is it loads the corpus, codes the information at the line level, not at the document level. So it focuses on reading line by line. In each line, it loads the dictionaries of actors to code the actors, then identify the verb phrases, then orders them according to the Arabic script. You have to start reading from right to left instead of left to right. Once we identify entities or verb phrases, we identify locations to make sure that those locations should not be filtered. And then we print the output. And the software does that line by line. So as you can see, something very basic, old school, very much in the lines of Tawari, not even universal dependencies like Beltrán does now. But again, this is just the concept of this, and we're going to work on some more additional expansions of the functionality. So using a very simple sparse or supervised coding approach, we develop a dictionary of 8 types of actors with a bunch of different individual organizations and leaders' names. And the interesting part here for us, in the substantive part of the project, is that we, in terms of the actions, we focus on 3 main types of actions: violence, with a bunch of different verb phrases related to physical violence and kidnapping and extortion. We also focus on governance, and governance has to do with, which is this third section, of provision of conflict resolution through the judicial system, and could be the religious one or the government one or the official one, policing and taxation. And we also focus on a third concept, which is Pashtunwali, which is the traditional way of governance at the village level in Afghanistan. And it has pretty much to do with the elder council involved in conflict resolution at the village level. This is why it was so important for us to focus on this type of activities. This is pretty much an example of how Hadath will code. In Arabic, you start reading from right to left. So these sentences: the Taliban attacked NATO soldiers in Kahanabad, in Kunduz, the province or the state of Kunduz. So the software will use the dictionaries. Red are for actors, green is for the action, and blue are for the department and the county or the district. And the software will pretty much, based on the dictionaries with codes associated, will produce a numeric output based on the textual content of the corpus. We apply this on Afghanistan, again, to focus on governance of non-state armed actors, and governance includes violence, but also the provision of public goods. Running this application through 26,000 stories using a dictionary of actors with 300 entities. The action includes more than 4,000, and the locations includes all the provinces and districts of the country. And we ended up generating 17,000 events. And this is pretty much the output by actor, actions, and locations of the study. First, we identify, well, these are the frequencies of detections. We identify that domestic actors, Taliban and warlords, the Mujahideen, are the most prominent challengers to the state. We also identify up here the presence of international armed groups. We have Al-Qaeda and ISIS present. And we also identify the other side of the conflict, primarily international forces through the coalition of international forces present in Afghanistan, and sometimes individual mentions of the US, the military, CIA, the general US forces. But it's not the only actor. We also have the national security forces, primarily the army, the Afghan army, the police and intelligence services. So the software clearly identifies the two main contenders of this conflict, but also helps us to identify here in green the importance of international actors like governments involved, international organizations, so multilateral organizations providing aid, like the UN, or different types of NGOs participating on the grounds, trying to come up with solutions to the tragedies that people live in Afghanistan. The software also helps to identify, given the prominence of governance, on religious groups and ethnic groups, which are very important in actors in the conflict. In terms of the actions, of course, this is a country in stage of war, so physical violence is a key element here in terms of the actions being detected, but we also see a very important proportion of activity related to governance, judicial governance, which is conflict resolution, policing and taxation. And also we identify a very prominent role of conflict management at the tribal level, at the village level, which is one of the advantages of using these enhanced ontology particularized for this specific case. So these are the different actions that the software helps us to identify. The location, everything is concentrated in the majority in the Helmand province, also in Kandahar, and we also have a lot of activity in Kunduz, Konar, and Host. In terms of the dynamics, the temporal dynamics, we see an increasing trend of activity across all different actors up to 2016, where between 2015 and 16, the US decided to withdraw troops. Then at the end of 2016, we saw an increasing presence of ISIS, which made the US rethink their strategy and recommit military resources to Afghanistan, and that's where we see the surge in 2017 and 18. So everything's according to the narratives here. And in this case, the software, I mean, in general, the software helps us to identify the different, in a very basic rudimentary manner. Yes, this is sparse parsing, shallow parsing also known. The software helps us to identify at least the basic components of who's doing what to whom, where and where in Afghanistan, focus on processing text in Arabic script. So at least we have the basic components of this. At this point, Hadath is very rudimentary. By the way, let me mention that Hadath means event in Arabic. So at this point, it's not a very smart software. We need to implement some part of speech tagging and tree banks, pretty much in line with what UD Petrarch does, to really identify in a more specific manner the semantic role of who's the source, what is the action being conducted, and who is the target of this action. We also need to improve or enhance the geolocation capabilities of the software. At this point is coding everything at the sentence level, but not all the sentences have mentions of the specific locations, because sometimes those are mentioned somewhere else in the document. So the next step of the geolocation algorithm will search throughout the document. And once we have a smarter software processing script in Arabic, we will make the necessary translations into Dari, Pashtun, and Uzbek, so we can actually process more information more closely related to Afghanistan using Afghan sources themselves. And with that, I think I'm still on time. With that, I appreciate your attendance and the support of the organizers to let me present this work.
Okay, thank you very much, Javier. And I don't see any questions yet, but I encourage all of you to raise your hand in the chat room or just speak up. I think you unmuting your mic. But in the meantime, I have a question, Javier, about the coding unit, as you called it, I think, the unit of analysis. As I understood it, you have a corpus that's divided into paragraphs, and each of these paragraphs is a long line or unit of analysis. And my question is, do you allow multiple events within those units, and do you reference events that might be split between units?
Yes, thank you very much for your question. Yes, you're correct. The unit of analysis, the coding unit of analysis here is the sentence. So we take the entire corpus, we break it down into documents. Each document has its unique identifier, and within the documents, we have unique identifiers for each paragraph. And the coding takes place at the paragraph level. And the paragraph could be just a sentence or a long paragraph composed of multiple sentences. So in this unit of analysis, the coder runs the dictionaries and helps us to identify whatever entities are mentioned in the sentences. This could include not only one, but multiple events. So in that way, the software has the capability of coding multiple incidents in the same paragraph. Also allows to code what we call SAT, which is the complete sentences or the complete sequence of source, action, and target, but also non-SAT events where one of the components is missing. This is because Arabic is a pronoun drop language, where sometimes the pronoun is embedded into the conjugation of the verb, so it's not explicit in the sentence. That's what we allow for these flexibility in the software. In terms of coding across lines, we don't do that. That is a huge problem for especially those who work in natural language processing. That is a core reference or an AFRA problem, where something is mentioned somewhere back in the text and we as humans can understand it, but the software is too dumb to do that. And yeah, we're limited on that regard. So we don't do core referencing across paragraphs.
Okay, thank you, Javier. I think Tariq had he raised a question in the chat. Go ahead, Tariq.
Yeah, thank you so much. Thanks for the great presentation and great job you did. I do have a question. From my experience, little experience with the GDELT, I can see that there are some similarities between what you are doing now and what is already offered by GDELT there. And even some more tasks are already there in GDELT. You can find them. For example, you can find what are exactly the actions between actor 1 and actor 2, and might be also actor 3. So I think all these details are offered by GDELT. So I was wondering to ask about what are the main differences between what you are doing and what it is already offered by GDELT.
So we have, yes, we're in the same line of well, thank you very much for the question, Tariq. We have similarities in terms of the family of coder that we are. All of these emerge out of Philip Schrodt's original work on Tabari. We have a few differences. The one that we have is that we're coding pretty much directly from Arabic script. I don't think my latest review of GDELT is that it doesn't do that directly from Arabic script. I could be wrong. I haven't updated myself on that. I haven't used it in quite some time. But we also have an embedded algorithm for geolocation, which is one of the biggest criticisms that have been put for GDELT. They rely on an additional external algorithm to eventually recode the information that we have from the text. And that has been criticized of lots of problems and double counting and this geolocation. And I think in that regard, we have a better application of the software. But in general, all these belong to the same family. Probably the next generation of coder, which is UD Petra, one who is finished working out the universal dependencies component of it, will be a much better software for solving many of the challenges that we have for natural language processing.
So you are dealing with Arabic directly or translating Arabic to English and then deal with it?
No, we don't. We work directly on Arabic text. We don't take any translations into consideration, even though the automatic translation skills or tools that we have are becoming better. But still, we don't rely on translation of any sort. So we take original text in Arabic and code directly on that using Arabic NLP tools and Arabic dictionary. So there's no translation here.
Interesting, because what GDELT actually are doing is to take Arabic text and translate it to English and then try to deal with it. So that is at least one difference. But I think also geolocation is offered by GDELT, and I had a look to that one. It seems that they use named entity extraction to get the names of cities and for example countries and so on, and then get their geolocation. So that is at least what GDELT are doing.
Yes, and it's not only GDELT, but my understanding is that IQs, they also have that similar translation. They take text from the original languages, they run it through an automated translation, and they code on the English translation, which might distort some of the content of the original language. That's why we wanted to focus explicitly on coding Arabic script. But thank you.
Thank you for that exchange. And I have two more names for questions. I apologize, I do not know how to pronounce Luna F. Could you please raise your question? And then Wayne is next.
Yes, thank you so much. And thank you so much for the presentation. What I'm curious about, since you're working with Arabic texts, could you elaborate a little bit on well, as we usually know in NLP, working with Arabic can be quite challenging because it's grammatically very different from English, and the tools that we have are usually kind of, well, they started at least in English, so they are either under development and also sometimes not very good for Arabic. Could you elaborate a little bit on how you work with that?
Yes. Well, first of all, I'm not an Arabic speaker, but we have Arabic speakers in the team. I have experience in other non-English language structures. The biggest challenge is that English is a very simple language where all the components are out. Basically, that means that the conjugation of the actors, the nouns, are not embedded in the conjugation of the verb, right? Which is the case in Spanish and also in Arabic. And that makes identification of entities a lot more difficult, because in the conjugation of a verb, you tend to include the gender, the number of the subjects conducting the action, and sometimes those get omitted, which is one of the biggest challenges of these non-pronoun drop languages. So for that, given that the conjugation of the verb includes the number, gender of the actors, it's a lot more challenging to do parts of speech tagging and tree banks, because those basically break down the structure of the syntactic structure of the sentences. But since you have the actors conjugated into the verb, that makes it a lot more difficult. At this stage, this is why we focus first on developing the dictionaries, and our dictionaries are very encompassing and redundant in including all the different conjugations for all the actors and for all the verbs that eventually could be mentioned explicitly or implicitly in the Arabic text. Other than that, I mean, that's a little more semantic or grammatical challenge. The rest was difficult in terms of the script. The script also has a lot of adornments that help the reader to emphasize the pronunciation when it's relevant and that it's very important. But not all the text, especially text from newspapers, they are deprived from these particularized punctuations or accents. So we have to clean all that from the text, also from the dictionary, so it's a lot more plain text in Arabic script. And that was another challenge, and also reading that was, in terms of the functionality of the software, probably reading from right to left, which is something very simple. For humans, it was not so simple for the software to do and trying to identify the sequences and putting everything together. I will say like the final challenge that we had is that Arabic script, the script is concatenated, it's like writing cursives in Latin script. So all the words go together, right? And they come these beautiful words. So all the letters come together and come out these beautiful words. And there are variations in where the letters are or the position. There are variations of the letter based on their position in the word. If it comes at the beginning, in the middle, or the end, and that was another challenge that we have to go through. Yeah, lots of little challenges, but we at least have a basic functionality in the software in place.
Thank you. And I think Wayne was next, and then we'll go back to the JRC.
Thanks, Doug. Thanks very much for a really interesting talk. We've been studying Afghanistan and the conflict for the past 4 years now, so it's really interesting to see this work. My question, though, is specifically about the sources, because we've only been able to look at English sources, and I wonder if you've got a sense of whether the events that are reported in the Arabic sources are similar or different from the events that are reported in the English language sources, including English language sources in Afghanistan itself.
Yeah, we haven't done that. That is a really good question. It's in the pipeline of the things to do. Once we have this, we will do a cross-validation above into English and then downwards into the what really matters, which are the news sources primarily in Dari and Pashtun, right, which are the most important ones for Afghanistan. So we haven't done that. We expect to see bias, as we see what we read in the New York Times is not exactly what happens or gets reported in other Arabic sources, and those could be also different of what actually gets reported on the ground in Afghanistan using the local or native news outlets. But yeah, we expect bias there, and eventually we'll be interested to test those things empirically.
Okay, thank you for that exchange. And then let's go to the JRC, please.
Thank you very much.
Yeah, thanks. So this is Vani from JRC. Sorry for the naming there on the window. I think it's because I launched the meeting with the account kindly provided by LREC. I don't think I can change the naming there. Anyway, so I have a couple of questions. So you mentioned geolocation. I was curious about which resources I mean, as a gazetteer, you use, whether you use geonames or something similar, and also the level of, let's say, granularity of, let's say, geolocation that you achieve. I mean, like the level of, I don't know, you mentioned county or district, or is that you cover also like small, kind of small size places, and that's the first question. And then the other thing is whether you have performed or you plan to perform some kind of correlation analysis with some existing, let's say, human hand-coded, let's say, data sets, if there are actually, for that time range. And because I think I see that one of the critical points about this approach, which is actually quite I think for Arabic language, it's probably one of the few existing ones, but is that you perform like extraction of events on a sentence base. So then, of course, the duplication of event records might be an issue, and then so it would be nice to see maybe to do a correlation analysis with let's say with some gold standard, which actually I don't know whether it exists for Afghanistan for that time range, but maybe you know more about that. Thank you.
Yes, thank you very much for your questions. For the geolocation, we use the same matching approach. Again, this is very rudimentary. We rely on the official names of these departments, which is equivalent to the state. And also we go down one further level to the district, which is equivalent to the county or municipality. In principle, we could go further down, but then we run into the problem of when I mean going further down to code at the village level. But this has a challenge because not always the villages are named. And once they're named, we could have multiple villages with the same name in different provinces. So we will be having a problem of geographic disambiguation that will be quite hard for us to solve, at least with this approach, which is not probabilistic. As part of another research team that I participate with based at the University of Dallas, we're developing software for a smarter way of geolocation using a software that's called Profile. All that is available in the UT Dallas event data website and in GitHub. But this is not something that we do right now in Arabic, in this particular application of Hadath. The way we deal with geographic disambiguation is that we have an additional dictionary of filters, things that could look like names names of hospitals or schools, or different entities that could be mistaken with the name of a state or a district. Then we clear those out. And this is how we deal with geographic disambiguation. And for the second point related to extraction and comparing that machine extraction to human coding, this is something that we're doing right now. We're coding a sample of stories using TACTalk, which is an online machine learning-based application that was actually very suitable for Arabic text, allows coding in Arabic, doing human annotation, and eventually will help. That will help us to validate the content of the machine coding that we're generating. At this point, we don't have a human validation for that to contrast it, but eventually we will do it. We're in the process of doing that. We try to do that also with Brad, which is another famous manual annotation software or platform, but was not able to process text in Arabic because of the alignment. Right to left, you have to highlight differently. The TACTalk is very, very handy for that. So eventually we'll have it, yes, and we're in the process of it.
Okay, thank you. I don't see any other hands, and I think as long as Phil has no objections, and since we do not have another paper, I believe we can move directly to you, Phil. Is everybody comfortable with that?
Yes, thank you very much.
Okay, so thank you, Javier, and it's all yours, Phil.
Okay. Is the screen visible?
Yes.
Okay, great. So first, I'd like to thank the organizers, and it's fascinating, the turnout here. A year or so ago in one of my blog posts, I said there were probably only 100 people in the entire world who cared about this stuff, and yet we had something like 70 yesterday, and I'm sure there's more, so maybe we're underestimating it. And we're all, of course, becoming accustomed to this Zoom format, which is not ideal, but from the perspective of a presenter, it has the key advantage that I didn't have to change planes at Heathrow. So what I'm going to do today, first, the slides are on my website. The slides are also, I believe, posted on the conference website as well. So they're available. I say that because I'll probably skip over some of this material. I'm not going to read all the slides, but it's available for you to check on it later. So where are we here? Oops. Trying to get the slide to change. Oops. Oh, there we go. Okay, so the reason we're all interested in this stuff is that we've had this advance in event data, and that between the computational advances and the availability of news on the web, we have the ability to a greater or lesser degree to provide more or less real-time data and to do it in a totally transparent fashion. And this is something we simply never were able to do. And I think the attraction, the reason there's so much interest in this topic is taking advantage of these advances to generate this data. But as Cleona pointed out yesterday, there are still some problems here. And it was kind of interesting. I'm sure part of the reason that everybody found this fascinating is we start out with the first keynote that Cleona is saying, well, you really shouldn't be using artificial intelligence on this. And then Phil is saying, well, really, here's all the reasons you should be using artificial intelligence. And so that looks like, you know, it's almost like next best thing to Game of Thrones, okay? Well, here's our list of problems, and I agree with every single one of these. And in fact, some of them are almost identical to the points I'm going to be making. And I think the difference is, first, focus. I'm going to be really addressing event data in the general sense, not just conflict or contentious politics event data. Second, I think we probably disagree a bit on the utility of short-term prediction. I think even if you can only do 6 to 8 weeks is useful. And then finally, and Ben Radford pointed this out, are we really using AI? I'm not sure, we aren't. Actually, that's a lot of my comments is we need to be doing more. And whether it's AI or more specialized, we'll find out. But again, the basic critiques that she offered yesterday, I have complete agreement with all of these. And again, I'm actually going to be skipping over some slides because she dealt with it very thoroughly, particularly the issue of duplication. So event data started almost 55 years ago, probably closer to 60 years ago, with McClellan's Weiss and Ed Azar's CopDad, human coded originally. And the interesting thing about event data, I always say, is it's never really caught on, but it's also never gone away, which is kind of intriguing. So, you know, here we are 55 years later, and we're still doing this stuff. In the 1990s, between our project at Kansas, KEDS, and then Doug Bond's Panda project at Harvard, we updated both in the sense of automating, and then Doug's project got us the sort of event data that we are accustomed to seeing now, with extensive use of non-state actors and things other than, the original data were basically interstate, and now we deal, the bulk of the data, for example, in IQs is sub-state actors. And then we've sort of carried on forward. The big investment was in the IQs project, which was originally 2007 to 11, and then it was extended for another 5 years by the work that produced the current coder. And it lost funding for a while, but it's been reinstated. It's now got secure funding. I'm not sure if it's on Dataverse yet, but it will be shortly. So that's kind of where we are. And the general type, again, I'm going to be talking about general event data. And here's the Weiss categories that most of you are probably familiar with. The Cameo, you're probably more familiar with, but it's not dramatically different. If we take that up to the present with Plover, which I'll talk about shortly, it doesn't look all that different. We got rid of the numbers, which shouldn't have been there in the first place. But the basic, you know, you got cooperative events, you've got conflictual events, you've got some that are kind of in the middle. We added a couple, the Investigate and Crime Renew. We consolidated some, we broke a few up, but it, you know, again, it's not dramatically different. So here we are 55 years later doing sort of the same thing, which again is a good thing, I think. The difference between just focusing on conflict, protest and violent conflict, and this broader stuff, I think is the sorts of questions we can ask. So this is kind of an arbitrary list that I put together quickly, but here's a bunch of stuff that you can look at that doesn't, you know, it involves some particularly protests, but there's broader questions than just looking at contentious politics. So we can look, for example, at the current issue of illiberal democratic transitions. An interesting one, the second one I've got, right-wing populist movements. Ben mentioned the possibility of using these very long time series. They go back into the middle of the 20th century, or even actually the 19th century. We don't have a lot of data, for example, on Madrid in 1930, but we do have news reports from Madrid or Berlin or Rome in 1930. And this is the sort of stuff that we can analyze with event data that we couldn't analyze, say, with public opinion data. It just wasn't available. Diversionary hypothesis, there's a request for proposals floating around on this right now. There's a whole bunch of stuff that we can do, particularly if we use these broader event data sets. Again, it's not a criticism of the focusing approach. I've done a lot of that coding myself and only semi-automated, but there's a lot of other stuff we can do. I mentioned that we've got these major changes in web infrastructure. We're pretty much all familiar with this, and this is both the availability of resources. It's become standardized. It's relatively inexpensive. Some of it's more inexpensive than others. We're getting a lot of new techniques, and this is where I think we can be using more, though Javier mentioned a number of, it used to be you had to explain what a support vector machine is now. Well, now it's become fairly standard. We've had huge changes in the natural language processing infrastructure. When we originally wrote KEDs in the 1990s, well, actually, even in Tabari, even actually in serif accent, the BBN coder, the parsers were internal. We didn't have parsing programs available. Now you can pick up half a dozen different types of parser. There's really 2 or 3 that are used. This thing called dependency parsing is very similar to what we want already. Named entity recognition, actors, organizations, states, and so forth, completely standard. We can supplement that with other resources like Wikipedia and JRC names. We've recently, just in the last 5 years or so, gotten the concept of word embeddings, which deal with the synonym problem, which is a huge problem in dictionary-based issues. And they don't deal with it perfectly. There was the comparison yesterday of Bert and Albert, two embedding methods. But again, the point here is that we've got a lot of stuff happening outside of the core, event data stuff that we can use to supplement what we're doing. And then finally, we have a number of different programs, not nearly as many as I wish we had, but Tabari, there was a lost program called Jabari, which was actually quite excellent. The current IQs is being done with the BBN accent program. It's sort of semi-open. And then the Open Event Data Alliance has several programs out there, particularly a Petrarch family of coders. And then we've seen other work being done. Javier, again, just presented some on these. So we've got these. Most of these are, at least some of them are open source as well. Well, actually, the only one that's not open source is Accent. Open Event Data Alliance, we've got a nice website. We obviously have this thing about birds, but a lot of stuff available out there. There's something like 30, 35 different sets of programs out there. Now, what's interesting is with all these coders, you get a very, very similar distribution of events. And I was shocked when I first read this thing, or ran this thing. So this is using 3 very different coders. The Petrarch family are actually quite different coders, and IQs, which is serif accent. As I say, if you do your eyeball analysis of variance here, clearly the between category variance is massively greater than the within category event, even though these are 3 very different coders. And there's a few differences. Again, I know how to read this chart quickly, but the BBN people did a lot of work on category 18, which is violent events. So that's that little green line that's sticking up there near the 20. There was actually a mistake in the Petrarch 2 dictionaries. That is the big yellow line halfway between 0 and 5. And then BBN also redefined one of the categories, the category 6, out of the way. But other than that, it's again, the variance is between the categories. It's not between the programs. Now, why is this the case? Well, a lot of this is just the news coverage. Okay, so our core source on all this is news coverage, one sort or another. All these automated systems have strengths and weaknesses, and I think it's not quite that they cancel out. As I just mentioned, the major differences you see there are the differences in the coding system, or in dictionaries. And this is not to say that Accent and Petrarch 2 in particular are the same. Accent's has had 5 years of professional programming development by some very, very competent computational linguists. So I'm sure it's a better program. But the overall, the marginal differences just aren't that great, which is wild. Okay, so here's my list of challenges. I'm not going to read through this whole thing. We'll be going through it. But what I would basically want to do is say, okay, here's where we are right now. With pretty much IQs as the state of the art. And there's a whole bunch of stuff that we need to be doing. And a lot of these are not, these are dissertation level or even master's thesis level type problems that you can experiment. And again, we've seen a lot of work just in this conference itself on this thing, which is really cool. And I'm sure we're going to be seeing more, or there wouldn't be so many people listening. So the first one, we need near real-time systems that are transparent. And at the moment, we only kind of have this. We sort of have it with the Phoenix systems, but we definitely don't have it in IQs. So open and transparent, every automated coding component needs to be available with no restrictions on experimentation. So the problem with IQs is, I'll talk about the problem in IQs, but the problem is it's not completely open. It's partially open. It's more open than some things. We need it completely open and transparent so that every possible problem and all the problems Cleona mentioned, we can see where these are coming from, and absolutely essential. And then I agree completely with her critique. We don't need real-time data. 15-minute updates are ridiculous. We need on the order of a couple of days a week. So I'll probably be saying real time, but I really mean near real time. That's more than adequate for operational purposes. Now, weaknesses in the existing systems. And again, this is not to say that these systems are bad or anything that they're the best we've got, but they still have weaknesses. So the problem with IQs, the coder, the event dictionaries, the verb dictionaries are proprietary. You can't get into them. My understanding is the license even says you can't reverse engineer them. It's easy to reverse engineer verb dictionaries from any coder, but apparently you're not supposed to do that with Accent. Curiously, I just discovered this a few weeks ago, the open actor, they have actor dictionaries out on Dataverse, but they don't cover most of the coded actors. There's some other dictionaries in there, and I think they're pretty mundane. It's not, their nation names in particular are not in the dictionaries, but nation names, just look at JRC names database. There are lots of different ways to do transliterations and so forth. Not as bad as things like Gaddafi and Ahmadinejad, but still, this needs to be transparent because you might be missing some major issues there. Geolocation in IQs is extremely ad hoc. It's not a sophisticated geolocation system like Mordecai. Coverage is very biased to Asia. I did a paper a couple of years ago on this, and it's not. IQ started out as a program focused on 27 Asian countries. You can still see that in the data. And where it's really focused on is it oversamples India. So I'm coding a protest data set at the moment based on IQs. And wow, is there detail in India. So if you want to study India, or you're looking for a place to study in massive detail, use IQs. It's fantastic. But that does mean that about a third of the events in IQs are in India, and that's obviously not, that's oversampling. And then finally, there's almost no internal coverage of China. There's external, Chinese relations. And then because of the funding sources, there's no coverage to the US. Then, okay, if you don't have coverage of the US and China, that's kind of a big deal in 2020. The Phoenix and Petrarch systems, again, the big problem with these is they're experimental coders. They were never intended to be operational. They're proof of concepts. And this is particularly true on Petrarch 2 is a summer internship project. Now, again, the guy that programmed it, Clayton Norris, is brilliant. He was a computational linguist undergraduate, he was a senior at the time, undergraduate, really, really smart guy. And he did an incredible amount in 3 months working for Keras Analytics. But that's all it was. And the Keras was hoping they could get further funding to basically, build the thing out, but they were never able to find that funding. I've actually worked a lot inside the code. It's robust code, or the version on the web now is very, we coded something like 2 million sentences without it crashing. But there's a whole bunch of unimplemented. When you get into the code, you find a whole bunch of unimplemented stuff. The other thing that worries me a bit is the verb dictionaries are radically different. They were modified from Tabari, but they're radically different, or actually from Petrarch 1. But and it's never really been curated. Again, they were hoping to do that. It just never really got done. So my general, and actor dictionaries have not been updated. So my general thing, again, one of my several snarky remarks to computer scientists is just because the code is on the web doesn't mean it's operational. And again, nobody claimed that Petrarch 2 was anything more than it was. But that's a problem, and that's where we need more work. So again, just briefly, I think eventually this work is going to need at least some professional staff. And again, that's where IQs has the advantage that was done by professional programmers, computational linguists. You can do some stuff with MA level and PhD level stuff with graduate students, but you're going to at some point have to go to some professional work anyway, but that's in the future. So the next issue, so my implication here is we should be writing another coder, right? Okay, but what should that coder look like? And Javier already raised some of these very issues, issues. And the issue at the moment is, do we go with the older style coding that goes back to the 1990s with KEDS of parsing rules and patterns, or do we go to the more contemporary example-based machine learning coders? And here's where I see is the arguments pro and con. The existing, and again, parser rule patterns is KEDS, Tabari, Jabari, serif accent, all the existing coders, these are well established. It's a mature technology and it's good enough. Okay, we've been working with this stuff for about 30 years now, or 25 years. Lots of stuff. You can do some nice models with this stuff. Open source code. For coders, parsers, dictionaries, everything. And a really key one is that the dictionaries are not affected by intellectual property issues, at least the open ones, unless, like with serif, the BBN is chosen to put at intellectual property restraint. But in general, those open source dictionaries are fine. There's no intellectual property issues. Disadvantages, dictionary development is incredibly labor intensive. This goes way back to the original work that Doug and I were doing back in the 1990s. And a lot of the dictionaries are still basically based on some of that stuff that was done at the Panda project and the KEDS project. Dictionary approach seems to be too brittle to work with machine translated. So you've got to go to native language text. Javier's got a very nice coder in Spanish, but that's really the only native language coder I know at the moment, outside of English. IQs is coded out of translated text, and some of those translations are really strange. And well, I'll talk about it later. And then finally, this is a 30-year-old approach. Now, lots of things are 30 years old. 737 is 30 years old, but it is an old approach and it's highly specialized. So the other possibility is to go with the more contemporary machine learning stuff. And again, huge innovations in natural language processing. And again, these are open, they're easily implemented, completely open. There seems to be a new neural network approach almost every week now. There's 30 or 40 of them out there, but there's software that will sort through them. And this is a project that doesn't need high levels of precision. Human coding is, realistically about 70%, maybe everybody claims 80%, but it doesn't hold up when you do it. So we can get fairly sloppy coding approach. It's very easy to generate, relatively easy to generate examples that if you don't get too picky about them. That's why I call them 10 standards instead of gold standards, rather than trying to figure out linguistic rules and patterns. So those take a lot of expertise. They're very, training is incredibly intensive on that, where it's pretty easy to get somebody to say, hey, is this referring to a protest, or is this referring to a agreement, blah, blah, blah. You can do that. And so for the other thing is, I think these machine learning methods will be more effective on the machine translator. That's yet to be determined, which is the big problem. This is still an unproven approach. I think a lot of people are experimenting with this at the moment. I certainly am. The other thing is, we don't know just how many training cases are going to be required. It could be a relatively small number, but it could also be a huge number. And even though these are easier to do than dictionaries, they still require a fair amount of labor. The other really big question, didn't fit on the slide, is whether we'll be able to use the existing dictionary-based coders to generate our training cases. And the answer, I don't know. We'll find out. Actually, I'm experimenting with that right now. And then finally, training cases in regular language, at the moment it's mostly English, are going to have intellectual property issues. So we can't just go get a bunch of stuff from Reuters without their permission and use these. So this raises the next issue, these are nicely related, of benchmarks in training cases. And again, at the moment, we don't have either. Particularly the absence of benchmarks is a major issue when we're talking about pushing this forward in the academic world. The big issue is intellectual property, that commercially generated information does not want to be free. And Reuters and Agence France-Presse and BBC and the 5,000 little, local sources with websites have a very legitimate commercial and property issue here. I'm not questioning that at all. So we got to somehow get past this, and I'll suggest 3 different ways we can do it. And we're going to need a lot of these, particularly in something like Cameo. I'm going to suggest we want to get past Cameo. But, if you got 300 cases, Cameo has actually got more than that. You're probably going to need what? At least 50 calibration cases. So, let's say, that's a huge number of cases. You can probably do less with something like Clover. And again, in the academic world, you can't get anything published unless you have benchmarks. I've learned this the hard way. And so we need these if we're going to get any help from computer scientists, if we can persuade them to work on this at all, which is problematic. And again, the big issue here really is the event dictionaries. Actors are more or less a solved problem. There's still some disambiguation issue. And by the way, the geolocation is still a huge issue. I'm not really addressing that, but it's a separate one. You can geolocate separately from coding, but it's really these event things, issues. So here's what I suggest: 3 different approaches, and any of these, or maybe all 3, would possibly work. One possibility is go the linguistics data consortium route, which they've got a thing called GigaWord. A lot of you have probably seen that, or at least those of you in the US, which is a whole bunch of news articles that have been licensed, and you can use it for non-commercial use if you can get access for it, but you pretty much have to be an academic institution or have friends in an academic institution to do that. And it's kind of dated. The second possibility is use synthetic cases, the cases that look like news reports but aren't. And this is sort of what I did with the Lord of the Rings validation suite and Tabari. There are ways of actually generating this using artificial intelligence. There's a couple of projects. So these would not be real news reports. They'd be indistinguishable in terms of the information from real news reports. So again, no intellectual property. And then the other possibility is abstract the cases so that they no longer have creative content, which at least in the US means they're not covered by copyright law. And here's an example of this that I've been playing with. So there's the original text, which obviously does have creative content. And then I abstract from this the stuff I need. So I take out all the identification of the actors, the agents, I go to lemmas, blah, blah, blah. I haven't run this by a lawyer, but I'm pretty sure that this is not, you know, it's certainly getting very, very close to something that no longer has creative content. So at least in the US, I'm not familiar with the European law, that would not qualify as copyrightable. And so that's also probably, and again, I'm still working on this, got the information you need for a machine learning thing. So that's a possibility. Cameo. Cameo is a problem. Cameo was never intended as a general purpose, and I say that as one of the co-authors of Cameo back 20 years ago as a general purpose ontology. It was adopted by the IQ's project, and they should have changed it. They didn't. And it doesn't cover a lot of stuff. So I've been trying to push Plover. This is actually a multi-institution thing. We haven't gotten as far. Again, we were hoping to get this thing out more than it has, but it's there. And so what Plover has basically done is it's simplified things by just going to the major categories in Cameo, which is mostly what people use. In fact, a lot of times they don't use that. And then using this fairly ingenious, I forget who came up with this, it might have even been Javier, thing called event mode and context. So you've got a triple, which replaces the hierarchical coding structure. And it's all in there's a pretty extensive, that document that I showed, the title page is actually about a 30-page document. And then the other thing it does is it gives a data interchange format, which allows the possibility of writing general purpose utilities. And this is done in JSON, which again, Ben showed an example. So this is what a Plover output looks like. So it's very human readable. And again, it's standardized. And standardizing fields is a pretty big deal, actually, because it does, again, allow this general possibility general utilities. But if anything else, it's a whole lot more readable than IQs. So that's what IQs looks like. And okay, you can kind of figure out what's going on, but it's not easy. And of course, storage is cheap now. Duplicate detection. Cleona just went through lots and lots of detail, and I'm completely right. I'm in total agreement with everything she was saying about that. We've got massive, massive problem of duplicates, and it's a problem. It's systematic bias. It's not random bias, so it distorts everything we're doing. And again, she dealt with that in great detail. I'm not going to go any further, but I just completely agree, and it's a huge, huge problem. And again, I come down to, I think one of the, in fact, I don't think I know, one of the papers yesterday, I'm sorry, I forget the author, but we need to get away from coded data deduplication. One-a-day coding is a really bad idea because it amplifies errors, to coding not just at least documents or identifying duplicate, at least documents, and I'd say clusters of documents. And that's actually what a human does. If you send somebody to figure out, well, what was going on in Madrid in 1930? Well, they'll read a whole bunch of different stories and they'll kind of put them together and so forth. Well, we need to do something similar to that. But the duplicate issue is totally out of control at the moment. Sources, here's an interesting one. And here again, I think in this case, Cleona and I disagree because we're coming at this from different places. We've got essentially three different sources. If we include the local networks. International sources like Reuters, BBC, Agence France Presse, and so forth. A whole bunch of local media, and again, thousands of them. They're all on the web now, but they really vary a lot. And just because it's local doesn't mean it's more accurate. And again, referred to that yesterday. And then if you're ACLID or a few other NGOs, you can set up local networks. I've actually worked with it. I spent about 3 years working at the local network in Palestine during the first Intifada, and these are fantastic. And they also provide a lot of employment, resources, empowerment, all the stuff you want. They're really, really cool. I completely endorse them, but I get very, very worried if governments start doing this. Okay, so if somebody, oh yeah, I'm reporting stuff to the US. Oh really? You know, that's not necessarily good for your health in a lot of areas. So I think this is something that NGOs can do, but those of us working more on the government side, or even the IGO side, the World Bank, IMF and so forth, this is, I think we have serious ethical problems dealing with. So local networks are great, but not everybody can do them. In terms of the major sources, I've done some analysis of IQs, and you get just what you expect you would get. The good old 80-20 or variants on that theme. IQs uses roughly 1,000 sources. It's fewer than ACLID, but it's a lot. And sure enough, the top 20 generate about 82% of unique events. The top 50 generate 92%. It's the usual rank size law curve, Zipf law, blah-de-blah, that you would expect. And it's definitely there. The other thing that worries me a lot about going on to this long tail of sources is they haven't been validated. Nobody has validated what the accuracy of anybody's coder is on some little local newspaper in in Eastern Congo, or radio reports out of, or transcribed radio reports. So the validation is usually on the easy stuff. That's highly structured data from Reuters and BBC and a few of these other major sources. And then again, Clariona talked a lot about this yesterday, that local elites have a lot of control over some of these. So just because it's local doesn't mean that it's accurate. So the possibility here is really you don't need the 1,000 or 5,000 or however many, that almost all your signal is in a relatively small number for these general purpose events. And then maybe we get a differentiation of tasks here. So the NGOs, whether it's ACLID or some of these other groups, Amnesty International, provide via networks some of this more local stuff. And then finally, native language coders versus machine translation. This is fairly quick, but the key thing, we've had major improvements in machine translation just in the last 5 years. And the older stuff, which is still used in IQs, is kind of dodgy. It's really, you can kind of figure out, but you can't even always figure out what's going on. Whereas there's huge billions of dollars, probably tens of billions being invested in this. And so it may get to the point where the translation's good enough that the pattern-based coders will work with translated stuff. They don't work very well now. The disadvantage is that we're dealing in a restricted domain, political events, and I've run into this problem with IQs, with translated text, is the texts that train these things are typically, well, there's several sources, but it's Wikipedia, it's parliamentary debate in the EU, and stuff like that. So it sometimes diverges quite significantly. So it really is just an issue. I think what we may end up with is this hybrid approach where you code on the translated thing, then you go back, you iterate, and then you go back and train on the original text and gradually improve things to the point where you've got the original text. But again, that's a PhD dissertation thing, or you could probably do a decent job with an MA thesis. So final thoughts. The first, and Ben mentioned this yesterday as well, and I think is implicit in this thing, we're not looking for one data set to rule them all. In fact, what I think is the strength of this approach and the strength of the fact that you can now develop this stuff. There's so much stuff out there in open source, ancillary support like parsers and so forth, that you can do this with a small research team. You don't need, a massive defense contractor like BBN working with a large team for 5 years to work on this stuff. Now, again, you can get too simple. And again, I think having stuff open is absolutely and completely critical. And that's where the sharing comes in. You get this collective stuff. But we will end up with multiple sources because multiple sources have multiple strengths and weaknesses. And then we triangulate between them. This has been seen a lot. We're all familiar with hurricane and snowstorm forecasts now. And that's how they work next. Then I'll finally end on somewhat weird set of comments. So the title here, may not be familiar with Tim Ferriss. He's kind of an odd guy, but he's rather successful odd guy. But he has this phrase that he uses when he's stuck on something. He said, "What would this look like if it were easy?" And I've used this a few times. It actually works out kind of interesting to give you ideas of, when you're stuck on something. So I'll just throw out two ideas here. And again, we want this easy, but not too easy. But some notions of just how much this stuff can change and how much we can do now that we didn't. First is a table from The Economist from this week or last week of showing what happens when SpaceX, a private company without the government bureaucracy, takes on the same task that NASA had been doing. And this is, which is get a person into Earth orbit. And what they do is they reduce the cost by about a factor of 15 on terms of development. They reduce the cost of actually getting somebody up there by about a factor of 6. And so the fact that it took NASA, $27 billion to develop the space shuttle, and it still didn't work, or didn't work reliably, doesn't mean that that's the only way that you can do things. It's the same thing. Again, BBN did great work. They've made a huge contribution. IQs has made a huge contribution. But the fact that it took them, probably about $10 million in 5 years in a full-time programming doesn't mean that that's the only way we have to go. And then finally, I haven't been able to track this down. I saw it, so I'm putting it as possibly apocryphal. But Google on machine translation, basically when they realized what neural networks and word embeddings are also neural networks, could do, they dumped 500,000 lines of code and they replaced it with 500 lines of neural network calls, TensorFlow. And that's, I think, the attraction that we have right now is the possibility, again, it's not proven, but at least the possibility of going to newer technologies that are much, much, much less labor intensive than the old ones. Again, we haven't proved it, but it's a possibility. So email, always happy to get email. Slides are here. I believe they're also on the website. There's the Open Event Data GitHub site. And if you're not familiar with IQs, the IQ site. And again, I don't know if it's been updated yet, but it's going to be updated. It's back. It's being produced in real time again. There was about 10 months it wasn't, but it's back and good now. Okay, so I'm ready to take questions. I'll turn off my screen sharing here. Put this on for just a minute.
Okay, thank you, Phil. And please, everybody, raise your hand or speak up. But I will begin with a question on at least one of your fascinating topics, Phil, and that is the notion of going beyond contentious politics with the events that we're coding. And you mentioned several examples, including illiberal democratic transitions and right-wing populist movements and things like that. And I just used movements. I don't recall whether you used that, but it's a more common unit of analysis when understanding those broad processes. And my question to you is, can you comment on the possible evolution of our unit of analysis for discrete events, and then more contextualization of those to include movements, campaigns, or any of the other larger units that are typically used when examining these? Yeah,
and actually, I'm glad you asked that question because one of the things I didn't say that is one of my criticisms of Cameo is that there's at least 2 major forms of events that Cameo simply doesn't code because Cameo wasn't designed to code it. And that's legislative behavior and electoral behavior. And by legislative, well, actually 3, coalition behavior in parliamentary democracies. And the same on the movements. We're somewhat in there. And again, the Panda Project, which was dealing with nonviolent direct action, began to do this and actually began to do it pretty well. If you actually go back to those earliest things, Weiss and Kopdeb, they coded a few institutionalized rebel movements like the Irish Republican Army and the Palestine Liberation Organization, but Yellow Vest, well, actually all these right-wing, or I don't even know if they're right, well, they're kind of right-wing and they're kind of not, but they're definitely populist movements. the big thing now is leaderless action. You see that in Black Lives Matter in the U.S. as well. You certainly see it in Yellow Vest. You saw it to some degree in Brexit. Tea Party, proudly in the U.S., was proudly leaderless. Okay, that's very different than the Irish Republican Army or the National Liberation Front of Vietnam, the Viet Cong, or the Palestine Liberation Organization. Those were highly structured. In fact, they were they were basically quasi-states, and quite deliberately so. Even Al Qaeda or ISIS are again quasi-states. But yeah, what do you do with Yellow Vests or Black Lives Matter, where there's not a single thing? I think but they're covered. Wow, are they ever covered in the media? So I think we need some creativity there. And then it gets really interesting when you start getting this. So for example, if you look at the large protests in Paris that started around the Yellow Vest movements, then you start getting green movements coming in. The Greens in Europe, at least, tend to be more organized. They have members in parliament. Then you get the anti-Yellow Vest movements, Red Scarf in Paris, stuff like that. We've got to figure out a way to code these much more dispersed groups. And I think, again, I don't know whether it's useful to go back to the New York Times in the 1930s. It'd be kind of interesting. Would we start picking this up, for example, in the left versus right wing street demonstrations in Munich and other places in Germany or in Madrid or in Spain generally? I don't know, but it's something that we've seen before, and I think we're going to be partly because of changes in communication, whether it's social media. It's both social media and one-to-one communication, whether it's cell phones or Signal or WhatsApp or whatever. We're going to be seeing more of this and less of the 1950s, 60s, and 70s. Basically, were the apex of state centralization and state-like entities. So if you wanted to be taken seriously, whether you're Irish Republican Army or the PLO or whatever, you organize yourself like a state. And now we're not seeing that. And we're seeing that decentralization. And I think our coding needs to accommodate that. Yeah.
Okay, thank you, Phil. And I think we have Kagri Yoltar, please.
Hi, thank you so much. Çağrı Yoltar from Koç University. Thanks a lot for this talk. It was very informative for me. So I actually have a question about ethical aspects, ethical dimensions of your research. You have touched this issue in your talk briefly, but I would like to hear more about your take on these ethical aspects. So because automated tools allow for the processing of large amounts of information in very short spans of time and may enable, at least like in the future, near real-time predictions of protest activity, they may at the same time pose significant risks to activists and vulnerable populations who are engaged in contentious political activities. So my question is, what measures do you take to prevent malicious actors like the state security agencies or intelligence agencies to use your data or tools for targeting activists, grassroots movements, or political dissidents, such as the Black Lives Matter or Antifa movements in the US, which was recently declared as a terrorist organization by the President Trump, or the Kurdish movement in Turkey, or peasant movements in India? Thank you so much.
Yeah, and I think that's a very serious issue that we haven't, the community that has not discussed as much as it should. Again, it's certainly discussed some, and I would differentiate. I have a very long blog entry on that I wrote about 2 years ago. My blog is, or if you just go to you can find my blog pretty easily. Anyway, it's secondmouse.org. But and I'll start with that. The blog entry was inspired by the realization that much as I wanted all this stuff to be open, like I argued here, there are arguments that if you're a state actor or a quasi-state actor like the IMF or the World Bank or some of the UNHCR, maybe that it might be that you don't want to make your models public precisely because that will allow, that will send signals that could be misinterpreted or that, you know, in a bad way or maybe in a good way. We're seeing some of this actually with the pandemic, with the WHO, and that, you know, models matter. We're certainly all seeing this with the pandemic. And, you know, at some point that might also be the case with some of the NGOs. I mean, some NGOs, you know, what I used to say, and I was being blasé about this, well, I was probably also being accurate, is that, well, we don't have to worry about this because nobody looks at our models anyway. So that was my standard thing, but that's not true anymore. These models, these conflict instability forecasting models are used by governments and major IGOs. So people do look at them. So there's that issue. The second issue, and the one that I'm quite familiar with, is protecting your sources. That's huge, particularly on these local networks. You have a huge ethical responsibility to your sources, whether they're activists, whether they're just, you know, people collecting data and so forth. And I just cannot overemphasize that. And I'm sure ACLID is completely aware of this and some of these other groups. Though the one other thing that I do think we need to keep in mind is this stuff is not secret. You know, the methods that we're using, whether you're government and NGO and academic, we're all using the same methods. And again, the reason I think transparency is so important is the signal that I can get out of Reuters, any reasonably trained computer scientist any place in the world, or political scientist for that matter, quantitative political scientists, can do the same thing. So is ISIS running models? Probably, maybe, or at least people who are sympathetic with ISIS are running models. Or now, not everybody, not, you know, there's probably, I don't know this. I mean, be interested to know there are kids in refugee camps running models on laptops. I'm sure they're smart enough to do it. They may not have the resources, but so we need to, and that again is where this issue of local networks versus public. If Reuters, AFP, BBC, Shenhua, All Africa, blah, 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 if the stuff is out there, everybody's got access to it. And they can run it through TensorFlow or Tamari or whatever just as well as anybody else. That's very different than if I've got a local network that I put together in Yemen or that ACLID put together, or in Gaza in the case of the ones that I was, and they know stuff going on that is not on Reuters and it's not on Shenhua and so forth. That's, and they're, as I say, the first and foremost is protecting your data collectors, but also the issue that you raise is my analysis of data that only I have, is that putting people at risk? And we'll take the Yemen example, or Gaza for that matter. You know, it's that, oh, so we didn't have any idea, you know, we just been watching CNN or Fox or whatever, and we didn't realize this was a hotspot of, you know, Houthi activity here, and so let's go, you know, destroy a village. There's a huge ethical component there. And again, that's where transparency on particularly your sources, but also, I mean, for the general stuff, if you're using public sources like the news agencies, is important. But yeah, it gets a lot more difficult on local sources. And we need to discuss, the collective community need to be paying more attention to this. So a very good question, thank you.
Thank you for that exchange. I don't see any more questions, but I have another one for you, Phil, while we're waiting.
I think Ali just raised his hand.
Oh, where is that? Okay, Ali, please go ahead. I just saw that.
Hi, I hear my own voice. Just, yeah, I have two. One is better. Do you hear me now?
Yes.
Yeah.
Yeah. I can't raise my hand because I am the host there. Sorry. I relied on the vision. Small questions that by the way, thank you very much, Professor Schrodt. We really took your time with all this communication and talk. We really appreciate it. It really made our effort quite valuable. My questions are you talked about translations, and the translation technology is improving, but in the same time there are cross-lingual models as well. So models that are trained on English data and can work on other languages, although not that good at that moment. Mm-hmm. So would you think actually they are these cross-lingual models are fed from the same sources with the machine translation tools? So maybe they're not easy to distinguish between them, but it will be, in terms of a pipeline, more practical. How do you think it would be preferable? Do you have any sense of which one would be preferable? This is one thing. Second thing, you haven't touched to social media. We are focusing on news. We have the word news intentionally in our title, but time flows, and maybe some issues in news articles, like yesterday's keynote, Professor Reyes mentioned the biases of the media may be remedied with social media data. Do you have any sense or experience with it? And finally, whether external sources, structured or unstructured data, would help us to improve these models, or at least evaluate these models. Maybe some crowdsourced information like Wikipedia event list. So these 3 points, if you could just comment briefly or extensively.
Yeah. I think the issue of machine translation versus native language coders is very much a moving target. My guess, there's 2 possibilities. One is that the machine translation will improve to the point where we can just do everything translated into English, without any loss of accuracy compared to human code, native speakers coding the language themselves. That's one possibility. I think a more likely possibility is that what we'll do is get a combination. We'll probably get specialized coders in major languages or language areas that are not well covered in English. So in particular, Spanish, Portuguese, Chinese, and Arabic, possibly Russian, maybe Turkish as well, or the Turkic languages. And so then if you've got an area where basically English is the lingua franca, or probably French as well, so much of Africa, certainly all of South Asia, then we can just do English. But if you've got an area like Latin America where it's Spanish and Portuguese, you still will need specialized Spanish and Portuguese coders. I think it's too early to tell, and it's still it's a moving target still. The second question was social media. Is that correct? And yeah, I'm skeptical. Okay, so there was a study that was done, very good. What's her name? Carly at Carnegie Mellon. I'm blocking on her name right now, but she did a nice study. This was about 5 years ago, maybe earlier actually. And what she found, so she was looking at the same sorts of questions we look at on conflictual type stuff. And she found the social media was good for about 6 to 18 hours for predictive models. And, so, one possibility is you get social media with a very short time. You get the sort of models that Cleano was talking about yesterday at that sort of 6 to 12 week area. And then you get these general models at the sort of 2 to 3 year thing. So that's a possibility. That was before the proliferation of bots, or at least before they were appreciated, and the massive amount of deliberately distorted information on social media. And this is done by state level actors, obviously, and multiple state level actors. It's not just the Russians. So it may be that particularly in this area of contentious politics, the signal is just going to be so noisy at this point that it's not worth doing. But I could be wrong. But I think the signal there is going to be very short term. You're not going to, the sort of general trend type stuff that people think they're going to pick up from social media. No, you've got to get that you can get that from the mainstream media. Okay, so now, of course, I forgot what the third question was.
Yeah, I was, and the third one, are you there? Oh, yeah, sorry,
Yeah.
maybe.
Yes, I'm
When we have the training data, we generate some. We are restricted with this time period, although we do randomly. After 10 years, it will be random for a certain little time period. So it's not, even we say we do automation, when we have the model, it will run. Keeping updating it is the other work. You would need to at least double check whether it still works. Would you have any external source that would have this check to some extent automatic, and maybe it could even help with the training or updating these models?
Yeah.
They are working on the bringing rule-based like lexicons to generate training data for us as well. So, but what would be your take from this?
Yeah, I'm optimistic about that. You've got 2 or 3 different large-scale institutions with stable funding now working on this. So again, IQs now has stable funding. They're aware of some of these issues like the actor dictionaries, and I think you're going to get much. Again, what we've got in IQs is pretty good, but it can be improved, and people are aware at IQs to improve it. Various outfits in the Joint Research Center of the European Commission, both European Media Monitor and some other groups working there. Again, long-term stable funding. The Views project at PRIO Uppsala is another one. Again, it's forecasting model. One could imagine that an IGO like the IMF or World Bank might take this on. So I think if you could get one or a combination, I mean, just look at the JRC names database, which is completely open, is a huge contribution to resolve the, 60 different spellings of Muammar Gaddafi. And that's open, and that's, again, supported, it's well institutionalized. So I think what we may end up with is pretty, it's happened for years with economic data, both national and international economic. So we've got some large, well-institutionalized, government-funded and IGO-funded groups that are providing the basic stuff. And then academics, smaller NGOs, research groups and so forth can go out and use that data, supplement it with their own data. So I think we're moving in that direction. We're not there yet, but I'm pretty optimistic about it.
Thank you very much.
Any other questions? I don't see any hands.
Yes, I just put it in the chat. Do you hear me?
Please go ahead.
Yeah. Okay. First of all, thanks for the very enlightening presentation. Actually, the issues that you listed and you elaborated are actually something that we should all think of. I mean, for the, let's say the next developments in this field. And I have one question on when you mentioned at some point that let's say the current standard data schema that we use, for example, the Cameo one, might be somehow limited, or like must be integrated with the further, let's say, event types, event categories. In your experience, did you get specific feedback from, let's say, existing models in social sciences, for example, in a conflict analysis and conflict forecast, specifically, about which additional, let's say, event types, and even with their corresponding metadata, possibly, might actually provide a better picture of this phenomenon. So what is kind of currently specifically missing in the current, in the let's say, the data schema that are used currently in this field. So like, for example, which other domains might be actually, might enter the picture. I'm thinking about, for example, economic phenomenon, also even humanitarian, let's say, a crisis, or even, I don't know, natural disasters, for example. Thank you.
Yeah, sort of two comments. One is, at the moment, most of the people I'm working with, this stuff is still so new that they haven't used it enough to see what they're missing. And then I guess the second issue on why there's not this massive demand to replace Cameo, even though I think we need to replace it, is you can supplement things. So, you know, natural disasters is something that should be in that data set. It's easy to code, but there are other lists of natural, you know, hurricanes, earthquakes, floods, stuff like that. You can get that. Elections, you know, there's plenty of, you know, there's websites where you can find lists of every election, every country, you know, for the year. So you can supplement that, but it would be so much easier if that data were in there. I think it's much less true of parliamentary stuff. So how do you distinguish between governments, you know, like Israel and Germany, that are going for months, if or almost years now, without forming stable parliamentary governments, versus ones that, you know, do it in 2 weeks, and so forth. Ben Bagosi and I did a paper about, it's almost 10 years ago, I think it was 2011, at the European Political Science Association meetings, where we took a large corpus of texts. I think we got it from IQs, or no, yeah, we got it from the research phase of IQs. And we ran a topic model on it to see what topics were not being covered by Cameo. And the ones that came out were the three that I mentioned in the slide: criminal behavior, electoral behavior, and parliamentary, both debate, but particularly coalition formation. And, you know, parliamentary coalition formation, like the problems you see in Germany and Israel, that generates a lot of news stories, because it's in capital cities where there are nice hotels. And those were almost, those three categories were almost 50% of the news stories. Now, again, that's not 50% of all political behavior, but that's a huge amount of stuff. And then, you know, I think we're now appreciating, both with the pandemic and with climate change, the importance of natural disasters, whether climate related or now, not just COVID, but, you know, Ebola, huge political implications in parts of Africa, both the initial lack of response and the very effective response later. So those need to be, and Doug did a lot of work in the early part of about 10 or 15 years ago on, particularly Doug Bond, on the VRA, on trying to incorporate this. So yeah, those would be the four things. You know, criminal is really easy to code because the language is so distinctive. The other thing that people do mention, this is the one that they mention, again, I'm mostly working with government, is cybercrime. I don't know why that as opposed to something else, but that's actually fairly hard to code because so much of it's anonymous. But again, you could do that.
I think Javier had a next question. Please go ahead.
Yes, thank you very much. Phil, thank you very much for these very enlightening comments. You mentioned this duality between rule-based coding and probably the next generation of it, using example-based coding, which will inform eventually machine learning and artificial intelligence. But what are your thoughts about using artificial intelligence not to code itself, the event from the text, but actually to enhance the dictionaries that eventually we will use to create better rules, more flexible, update them without so much of that huge manual effort that eventually will those rules to code the events. So what do you think about that connection?
Yeah, I think that's another distinct possibility. Again, another hybrid approach. So the way you do, I've actually experimented with that. The way you do that is you do the parsing, and then parsers are open source. Dependency parsers give you almost all the information you need, and you see you look for. You probably would run kind of a topic model type stuff, but not exactly. I haven't quite figured out how to do it yet. But you would you would try to extract the common patterns out of the parsed data using automated methods and just looking at frequency. Yeah, there's a program on my website, my GitHub, called Mudflat that is sort of initial work. I've kind of been distracted now by the possibility of using neural networks and getting away. But yeah, I think that's a distinct possibility. And again, the nice thing about that is it's multilingual. So you can get dependency parsers in like 52 different languages. And certainly you've got high quality dependency parsers for the major languages like Arabic and Spanish, Portuguese, Chinese, and so forth. And so go from the dependency write a coder that can use a dependency parse, which is pretty easy. It's just a few hundred lines of code, and then extract the patterns and go from there. Yeah, I think that's a distinct the thing that I haven't mentioned all along is the reason this is a hard problem, the reason computer scientists give up on it, I've seen this both in academic and commercial applications, is assigning the target actor. The source actor is easy. It's almost, at least in English, it's always the first actor, almost always. And so that's where the patterns have an advantage over a simple classifier. And so far I haven't been, Andy Halterman's doing some work on that. So where patterns can identify where those source and target actors are, and if you can extract those automatically, yeah, I think that's a distinct possibility. And again, in multiple languages, not just in English.
Bill, if I may pick up on that point, you've been talking about the example based rules versus the rule-based and patterns. And regardless of the level of optimism one has for machine or the ability to encode by rules, I'm curious about your current view of the maximum or the optimum. You had in your slide that we are nowhere near 100%, which I think is pretty obvious. But given the fundamental ambiguity in how we use language and the fact that all language is a mediated perception of reality, clearly that says, I think you were implying that we're not going to get to 100% even with a perfect machine. So do you have a viable, realistic target that we should be aiming at? Is it 85? Is it 90? Is it probably above 70, but is it maybe maxing out at 90? Or what are your thoughts on that these days?
Yeah, okay. Two different thoughts. One is it's going to vary tremendously on the type of event. So a meeting or even a protest is very easy to code. And you can probably get up to 90 on that. An agreement is hard even for humans. You know, that's why we have civil lawsuits. Is, you know, I thought we had a contract. No, I didn't sign it, blah, blah, blah. Okay, so, you know, an agreement or a demand, you know, those maybe, I don't know how low we get. So I think the first thing is we need to get away from the notion that there's an overall accuracy. No, there's an accuracy for a particular event and a particular source. Reuters is going to be easier to code than you know, some of these local sources that have totally different journalistic styles for, you know, lots of cultural, historical reasons. I think the overall accuracy, to me, the benchmark where I start thinking I've got operational, you know, useful stuff is 75%, which sounds really low. And Tony Tether would go freaking out on that at DARPA because, you know, it's not really science. Well, yeah, look at weather forecasts. And we live with weather forecasts that, okay, so there's a 30%, looking out my window, there's a 30% chance of really big thunderstorms today here in Virginia. Well, that's useful information for me. I know it's not 100%. I know it's not zero. I know, that's fine. We don't live in a 100% world. And I think, again, your observation that political text in particular is it's culturally mediated. It's contingent on the circumstances, and again, some things are unambiguous. Again, a lot of the stuff we've been talking about, coding, uses of force and protests is relatively unambiguous. But you start getting into, is an election fair, or how do you evaluate that? I mean, again, people debate that endlessly. And I guess that's the one other point I would make that I think I made in the slide, but I've made elsewhere. People get hung up on debating the coding of individual events. And this has been what's hung up a lot of the work in IQs. We had the problem in KEDS. I know you guys did in VRA as well. If it's ambiguous, don't code it. Don't put it in your training sets, because the machine's not going to be able to figure out. Use your training sets, or your whether it's for machine learning or whether it's extracting rules, the way Javier just suggested. Make those the unambiguous cases, and then let the machine figure out the ambiguous ones. I don't think the machines are going to be any worse than the typical coder. I mean, lots of us here on this call, I'm sure, have done a lot of work with coders and human coders. They're not really consistent. And I know we had a wonderful panel at ISA about International Studies Association several years ago, where a bunch of large projects, we got together and talked about these, but we all have exactly the same problems. With the coders get bored, they quit, they don't even forget what you told them to do, etc. The advantage of machine coding is the machine's going to be consistent. It may not have that optimal accuracy of 90% that you think you've got, but at least it's going to be consistent, and you can see where the problems came in. You can see, oh, I'm doing a really lousy job on leaderless protests because I don't have enough examples in there. I've only got highly organized, institutionalized groups protesting, like the political party. So I need to put in more leaderless protests that are much more diffuse, and multi-topic protests. And then I put those in, and oh yeah, my accuracy improved. So as long as it's open, again, both your algorithms and also your trainings, then you can correct things. We're not remotely close to 100%. Now, I think 75%, you can get a usable signal out of 75%. Yeah.
Okay, thank you, Phil, and thank you to all of the people who've raised questions. I understand from the organizers that we do have just a few more minutes. If there's a final question, I think maybe Phil can entertain that. Is there one more, Ali? Go ahead.
Yeah. So I was reserving this question only if nobody is around. Actually, my other colleague has one. I just see now. Maybe I can allow Fouad to ask, because he's our annotation supervisor and he's political scientist, and he knows really a lot of details that my mind can't comprehend. Therefore, I would value his question. Fouad, do you hear us?
Yes, I do. Thank you. Thank you so much, Ali. I'm trying to turn on my video, but somehow it doesn't work. Okay, sorry. I think I'm going to have to do this without the video. Professor Schrodt, thank you so much for your enlightening presentation. You raised many issues, and I really wish we had more time to listen to you elaborate on many of them. My question particularly involves the problem of duplication and how to deduplicate. What would you say the biggest factor which causes this particular problem to rise is, and how would you what would you recommend to what should we think of in terms of ways to mitigate this problem? To my mind, it seems to a certain extent, at least, it's an accuracy problem. So insofar as you can detect the location, time, and actors of a specific event with reasonable accuracy, it should be much easier to address. And yet we see, as you mentioned, a systematic error in large data sets of duplication, and remedying this via ways of limiting 1 events per day, etc., as you said, also hampers the overall reliability of the data sets. So would targeting higher accuracy in terms of time and location and maybe participant actor information would remedy it, or should we deal with it as a separate problem to accuracy? Thank you.
Yeah. I mean, you've identified the issue correctly by far. I guess I'm skeptical that we can get the accuracy in automated data high enough. And let me just start by noting the problem we have at the moment is the 2 big data sets, which is IQs and GDELT. We've managed to go this long without mentioning GDELT, don't deduplicate at all. They don't even try. And the problem is people are using these data sets without looking at the duplication problem. So again, the duplication is systematic. It's not random by any means. Now, in terms of the accuracy, the problem is there are just so many ways that these coders, particularly certainly the rule-based coders, can go wrong. Just something as trivial as somebody misspells a place name, so it's accidentally displaced 200 kilometers away from it because there's another village with the same name, but it ends with an A instead of an O, so it accidentally displaces it 100 kilometers or whatever. There's just so many ways that thing can go wrong that I don't think we'll ever get the accuracy to a point where we're going to eliminate those sorts of mistakes. And again, the big problem of duplication is just the same people are repeating the same events. If it's a yellow vest demonstration in Paris, that's fine. We can deduplicate that and so forth. What worries me is this diffuse, and you saw this in a lot of Konona's slides yesterday, where you get this lots of misplay. Well, first, never geolocate something to either the geographical or population center of a country, and start with that. But leaving that aside, you're still going to get these odd cases that are where events are not happening, and they're going to sneak through. And that's why I think this idea of either document or really, I think, cluster-based. We've got lots of really good cluster algorithms. So if I've got 100 reports of major Boko, well, I won't have 100, but I've got 10 reports of a major Boko Haram attack. See, most of these will be correct, and just get the one that has, this occurred in Mogaderi or whatever, and not in some village that is a misspelling of it, or a lot of cases it's just transliteration issues. So I think coding out of documents and then taking the most frequent, set a threshold. Maybe if an event is not mentioned in probably a low threshold, let's just say 70% of the documents in that cluster, then assume it's an error. I think that's the way to go. But again, the big problem at the moment is these 2 large data sets. They claim to be coding, massive thousands or hundreds of thousands. They're not. Most of it's duplicates. I mean, in the case of, it's probably 70%, even in IQs, is probably duplicates. In my case, at least 70%, probably more.
Okay, thank you, Phil, and thank you all the questioners. I think I'll turn it back to the organizers at this point. We're at, I don't know what time it is there, but I thought it was our full time. So I appreciate the opportunity, and it was a very enjoyable, very provocative, very stimulating discussion. So I'll turn it back to the organizers.
So our time is up. We have a buffer time 10 minutes, but I think a lot of things are clear, and we will follow up with emails, especially about a panel tomorrow. And would just like to thank Professor Schrodt and all people around here who are with us to recognize these issues and hopefully proceed more aware of all this stuff. And in any case, for any information request or issue, just throw us an email, especially these couple of days we are online. Just want everything to be to run smoothly, especially in this new online environments. So thank you very much, and hope to see you tomorrow and in the future. Bye-bye.
Bye.
I think we can just close it maybe, and okay.
Yes.
Bye-bye.